Welcome back. So I've just last three streams I've just been testing these three methods of recording the number of times a signal has been turned on and off, and I've decided to go with this method here as it's the simplest and most reliable likely. So what remains to be done now is to install it over here. In this, the binary adder. I need to get rid of this. Reminds me I need to back up this well. I haven't backed up in a while. should be the correct orientation. Ah, it's not. Look at that, that's perfect. Perfectly annoying. I wonder if that line stays there when I undo it or if it breaks. Huh, it survived. Okay, that's how I want it. Except that's the return line, isn't it? See, this needs to be one closer. Now it can reach that. So I need to plumb this into systems out the back here. So when it's in state 2, this needs to be on. That switch, no, this needs to be off rather. That switch needs to be open, which means that needs to be off, which means that needs to be on in state 2. So in state 2, that is now open. Yes, that's correct. And this needs to be red too, so that's on. This should be off, but it's just on by default. Okay. So in state 3, that reads why is that all of a sudden off? Have I broken? Yes, I have, haven't I? Now when I flip the switch, it should go to state 3. Which it does, only that's not close enough. Go back to state 0. I didn't flip it fast enough, did I? Rather, I flipped it too fast. So let's try that again. State 3, it should go to state 0. But it shouldn't go to state 0 before it's turned back on. Yeah, that's broken, but how? So that's the return line. When I switch that off, that opens that switch, which allows that signal to propagate down. Signal will I know what. I think that's what it needs. Just remember, this loop isn't technically supposed to be like this. Stays on, turns off, goes to state 0. Stays in state 0. Should go to state 2. It goes to state 2. Well, state. Why is it still in state 0 as well? It should just work. Also, it occurs to me now I could have just lumped those return lines all together, I think. Why is this not shutting down that? So it is. Oh, hang on. Have I added a I've added a loop, haven't I? It's just looping around here. Fix this by putting one of these in instead. State 2. State 3. State 1. State 2. State 3. Right, now, so the CPU needs to know when this binary adder is in the read state or the write state, right? So basically it needs to be because the CPU needs to either read from the memory or write to it. It needs to know which one it's supposed to be doing, right? And it can only note that based on what state this is in that there. Otherwise, I'd have to do the same thing over there, which would be a lot more complicated, just because I'd have to. It'd be marginally more complicated, but it'd be quite stupid, I think. Either way, what that means is I have to return this signal here to the CPU. The CPU will know that if this is 1, then it's in a read state. And if it's in a return state, let's say, so it's sending data back towards the RAM. And if it's in a 0, it's in a input state. That's why it doesn't actually have to be particularly fast, because it's all happening whilst the CPU's cycling anyway. So it's like it's propagate. It's got all the time in the world to propagate, basically. But still, I'll make it fast. Okay. Needs a bridge. ultimately this data from here will feed into this one of these two black or white lines over here, which are the read and write lines, read and write bits rather. Which reminds me, I'm going to have to extricate them from there somehow and bring them out over there. That could be annoying. Can they go through? I don't know. Well, that'll be easier to bring a line into there to meet them, won't it? Rather than bring the two of them over. But yes, that's a problem for another day. Now, obviously, with that return line put in, and I'm not sure what I'm going to do with the timing line, which is the purple line. I don't know if it needs it or not. Well, all I have to do is just tie this into the address operator, and also I need to officially set this address to 0000, which is binary 0, right? Because this is the first operator on the line, right? Basically, this bus here is the CPU bus, and this is the first operator connected to it. This is the binary adder, and it will be at address 000. This here is the address sensor, right? This detects if it's the right address or not, basically. Set that to 0, set that to 0, set that to 0, and set that to 0. So now the binary adder, is available at address 000. So if all of these bits here are off, currently this is quadruple 1, right? So this is representing address 16, but if these are quadruple 0, they would come in here and they would match to this, which would turn this on, which would tell this to accept data from the CPU. Which may be a good point, actually. Is it actually what does it do in the passive off state? In the passive off state, it should do nothing. But I actually need to put a switch in over here. If you think about it, right, even though it's technically doing nothing, what it actually is doing is it's propagating redstone signals around here and through here. But because that address is off, it's not actually loading or saving anything, so it's basically irrelevant. But still a problem, because that might generate lag on my actual computer, right? My actual computer might get lagged out by that because it's calculating signals going around here, even though it's not actually calculating anything full stop. And also I need to do that. Just adding another tick of lag into the whole thing. Very annoying. Well, I can probably mod it so it's not so the tick is much faster, I think. Likely I can. I don't know enough about micro voice to know if I can do that, but I suspect I can. And if not, we'll be enjoying a glorious one instruction every couple of minutes. I'd probably be more like several instructions a minute. Anyway, that's that. Now, yes, so that was it. I was going to build a switch. I actually discussed this before, but I need to build a switch across here so that all of these repeaters don't fire, and also none of the circuitry in there gets fired, and that will hopefully reduce lag. Although there is actually a third line of defense here, which is chunk loading. Because obviously this is such a big computer, it's all going to be outside of my chunk loading range. Like, almost all of the memory over there is invisible, right, outside of my chunk loading. What I've done is I've set up a system of chunk loaders, which activate on these memory addresses. And I'll need to do that here. Well, I'm not ready to do it yet, because I haven't figured out how I'm going to do it for the CPU. But that will mean that that's not loaded and therefore not producing lag. Therefore, I don't need to worry about putting a switch in because it's not going to be loaded, so it won't generate lag. But this main bus will have to be loaded all the time, so I still do need to worry about these generating lag. Use orange for this as well. Oh, should I use orange? Yeah, I think I'll stick with orange for it because it is a control signal. So yeah, basically the purpose of this switch I'm about to put in is to reduce lag. Lag in my actual computer, not the Minecraft computer itself. It's a NOT gate. You get more lag. So if I just put this way over here, that should be further away than the when that fires, that should turn off. Excuse me. Excuse me. This thing's going to be a bit obnoxious on the eyes. Oh, for God's sake, it runs out right there. No, actually, that's fine. It's not, because it can't be on a corner. Still fine. Switch 1. Ah. It's not got much range, has it? I suppose I was kind of hoping it would go further than that. I think I'm going to mess up that if I put this here. Answer yes. This may be harder than I anticipated. What I can do is I can put those switches there. Put an array of switches in there, and then I can put see that works, and no, it doesn't work, in fact, because of the feedback from that. Ay, ay, ay. I don't really understand that logic. The way this at least is easily fixed. So that's a switch for that case, at the least. Just need a switch here. is, of course, it doesn't work. We're really pushing these to their limits now. Like, how many insta wires can you stack in close proximity before Minecraft code breaks? Not to mention the now horrific aesthetic. You know what I can do? I can put one here. Except I still can't. Oh no, I can actually. Then I can connect it around here. And I think I'll switch those two off there. And do remember that I won't have to do this over and over again, because the whole point is this is going to be a copy and pastable unit. So I only have to do this torture once. And it is torture. It's killing me building something this messy. Look how ugly this is. May as well fill the rest of it in as well, so it looks a little bit neater. Okay, that's not gonna work. That might. No, it won't. That's strong enough to do that then, okay. This won't be strong enough to do this though. It will be strong enough to break the whole circuit. Except there isn't even room there. Any way I can fix that? No, not with 2 block space. Certainly not. Just to go up 1 and down. Switch here. Does that? That gets there, yes. One thing I never checked was if these are still instant when they're in that configuration with the block at the end, because sometimes they do weird things. But anyway, I actually need to do this. Honestly, you know what, I'm not doing it like that. There's one crucial problem with this whole setup here is it needs to be in line with this, because this is where I copy from. So if I go beyond that green line, if I go beyond this, it'll make copying it very complicated, because then I'll have this bit here cut on in a way that I don't want it to. So I'm just going to build a redstone spiral staircase and pray instead. this. And that's switched all of these off except this one, which is stuck on for some reason. Stuck in a broken state. So I need to switch those ones off and then these two off, and that's going to be done with a separate line coming along here. God, that's ugly. Well, I can fix it a little bit. There, you see, it was clearly always meant to be this way. Well, that's those two switched off. So it's these four, or these three? These three at the end here. Oh. Oh, I have a pathological need to never complete anything, so I just want to switch off now before I put this out, before I finalise this switch. But you know, I'll push through and I'll finish it. I'll finish it. Much as it galls me to finish something. It's not going to work. Excuse me. Sorry. That is correct. all I need is to extend it over here. Like that. Now every line should be cut off. That's cut off, that's cut off, that's cut off. Yeah, they're all cut off now. If I switch the switch down here, if I do this, they should all turn on. They're all on except the red one. Where's the red one? Off. Okay, so there's a loop there. But how to fix said loop? Well, it's simple, really. So they're all on except that one, which is off because there's a broken wire there. So they're all on. Yes, and now they should all be off. Which they are. Oh yeah, they're all off. Look, they're all off. Ah. That's very sloppy of me. Especially when I can just do this. Rotate 270. Of course, it still doesn't reach naturally. How do I stop that? Come on, big thing, big thing. Incredibly lazy solution. At this point I just need to get it built though, so lazy is good. Like that. There are all yeah, it's just a little bit concerning that these are breaking. Like, it could have broken potentially because of this signal here. In which case, that would be a problem. Like some of these. Oh yeah, that's broken. Let's test this again. Should be all on. Yeah. Yeah. Nope. It's off. Because it is broken, it is off. Was it broken before, or did it break when I just cycle it again to find out? Should all be off, those off. That's on, so that is firmly in the broken category because of that. Will putting that there break that is the question. Oh, I see, that's why. Actually, that stays on despite that. Also, why isn't this breaking these? Like, surely that should be breaking that. Of course, that's in a loop with itself, but I can have a slow line coming this way. Slow line coming this way. Straight into that, and then there's no loop, and then that's still on. Damn it. Does having that there affect that? That's an interesting question. Does seem that that breaks it. Finally that works. They're all off. It's hilarious that it's easier to see if redstone signals are on or off in daylight, even though they're supposed to be brightly illuminated. They're all on, guys. They're all on. Because I've created the loop somehow. That's how. Those are on. Those are on. Those are on. Good. Off, off, on, off. I'm assuming that... No, that's not being interfered with, so... Why is that on? It's because of that. Oh right, it's because it's I see. So I need a diode here. Zero latency diode. Now they're all off. On, they're off. They're all off. Because this guy has, no, because this is, diode needs to be going the other way, of course. So the whole point of that line is that signals yeah. So what I don't want is signals back propagating along here. That should now work. Those are all on. Those on. That's on. Those all off. Those are all off. Those, of course it didn't work. Because I built the diode the wrong way around, because I am not so smart. Someone is in fact not so smart. Now they're all on. Now they're all on. I don't know why these aren't interfering with these, but they aren't, so I'll take it. Like that line there should surely be interfering with this insta repeater. Hang on, maybe it only does it if it's one above it. And maybe if it's on a level it doesn't do it. Anyway, I'll take that for now, and thanks for watching. Now, I'm probably going to do more regular streaming schedule, like, so considering I'll likely regularly stream on a Tuesday night and a Friday night. And then I'll stream in between whenever I feel like it, which will be probably frequently. So I've got to get this thing built. And obviously, it could use doing short bursts, because that's how long my attention span is for like complicated problems like this. It's like, right, an hour, and after an hour I'm done. So yeah, yes, but that's that, and thanks for watching. Don't forget to like or check out the VODs on YouTube's. Ugh, excuse me. Good night.